Welcome to this lecture. In the last lecture, we had discussed about the different types of relationship that can exist among the classes, and then we said that there are 4 types of relationship that can exist among classes, that is inheritance, association, aggregation composition and dependency. We looked at the inheritance relationship with some examples, and we saw that inheritance is a powerful mechanism and also easily implemented in code. Just by using a keyword, we can implement the inheritance relationship, and then we were started to look at the association relationship. We are looking at how to represent that in the UML syntax, and also how to implement it in code, and what is the implication of the association relationship between classes. Now, let us proceed further understanding the association relationship. The association relationship is represented by a line here and sometimes by an arrow, we will see later when, and we write a multiplicity number here. So, we read here, and this is the name of the association, the person or the people associated with a tax file. One person associated with one tax file, or one tax file associated with one person. If we look at the corresponding objects of these people, we will see that there are many objects, Rakesh, Shukla, Bhi, Ramesh, Keshav, Pari, etc. And then the tax files are having different numbers. So, each person here, each object, people object here is associated with a tax file, but then there can be some objects here which do not have, which are not associated with any tax file. So, that is permitted by this relationship. As we proceed, it becomes clear that why that is the case, that some of the objects, people object is associated with a tax file, but some are not. Here woman, a woman is mother of many persons, but we can also read it as a person has a woman as mother. Please pay attention, I will read it again because this is important. We read this relationship, this is the association relationship between a woman and a person, and the name of the association relationship is mother of. We can read it as a woman is the mother of many persons. A woman is the mother of many persons, that is the implication of the star. We can also read it as a person has one woman as his mother. If we look at the corresponding object diagram, that becomes clear. The woman class is instantiated into many women, and one of the women here is Kunti, who is the mother of many persons here, Bhim, Yudhishthir, Arjun, etc. But Arjun has exactly one mother, Yudhishthir also has exactly one mother. So, that is what it says, a person has one woman as mother, but a woman can have many persons. Woman is the mother of many persons. This is the syntax in UML. We write the two classes which are related by the association relationship. We draw a line here indicating the association relationship, and we write the role here. we will see what exactly is the role. For example, a person and a company are associated because the person works for the company. The name of the association relationship is works for. We represent it in the form person works for, this is the reading direction, name of the association is works for, these are the two classes, and the role of the person is the employee and the role of the company is the employer. We can write that or we may not write, but then in the case tools we will see that if we write these two, it helps these become attributes of the corresponding class. The person works for a company and the role of the person is the employee and the role of the company is the employer. These are more examples of association. How do we read this association? A member borrows up to 5 books. A book is borrowed by a library member. A member borrows up to 5 books. Okay, I should have written 0 here instead of star. Let me just change that, it should be 0. 0 to 5. A member borrows up to 5 books, or we can read in this direction that a book is borrowed by exactly one library member. Now, this one, a lion eats many humans. A human is eaten by many lions. So, the multiplicity that we write here it indicates a single object here is associated with how many objects on the other side. This is important. The multiplicity indicates one object here is associated with how many objects on this side. A lion eats many humans. A single object on this side, a human, is eaten by many lions. Similarly, here the multiplicity here is 1 and here it is 0 to 5. A library member, that is a single object here, borrows up to 5 books. A single object here, a book, is borrowed by a member. Now, let us look at the arrow here. If we put an arrow here, that means that the key can invoke a method on the door, but the door cannot. It is navigable from key to door, but not the vice versa. If it is a simple line here or a bidirectional arrow, the navigability is on both directions. Now, let us see how we can read here. A key, that is a single object here, a key opens up to 5 doors. A door is opened by many keys. Now, let us see how to draw a class diagram given this description. A teacher teaches 1 to 3 courses. Each course is taught by one teacher. A student can take between 1 to 5 courses and a course can have 10 to 300 students. So, the classes here are teacher, course and subject. A teacher teaches 1 to 3 courses. A course is taught by exactly one teacher. Teacher teaches up to 1 to 3 course, this is the reading direction. If we write the reading direction in this direction, then we write course taught by. If we write this is the direction, if we give, we will write the relation, the association is taught by. And the next one is student can take between 1 to 5 courses. Sorry, this is the student. This is the student. A student can take up to 1 to 5 courses, and a course can have 10 to 300 students. And we can write the name of the association relationship. A student credits 1 to 5 courses. Let me put the reading direction on this credits. So, that is the same diagram here. A teacher teaches 1 to 3 courses and a student takes 1 to 5 courses, or a course is taken by 10 to 300 students. Given a description, we should be able to identify the classes and the association relationship, write the multiplicity and the association and the reading direction. Now, please do a small quiz. We need to draw the class diagram. A student can take up to 5 courses. Student names to enroll in at least one course. Up to 300 students can enroll in a course, and an offered subject in a semester should have at least 10 registered students. Please try to draw the class diagram for this. The first thing is to identify what are the classes here. Student is a class and course is a class, and we represent them a student and the course. A student can take up to 5 courses and need to at least take one course. So, we write 1 to 5 and student takes, write the reading direction here. Up to 300 students can enroll in a course and it must have at least 10 students. So, we write the multiplicity 10 to 300. So, this will be the class diagram for this description. So, that is what we have written. Student takes or enrolls in 1 to 5 courses and a course has enrollment of 10 to 300 students, and we can also write the role, the student credits and the course has enrollment of. How do we identify which diagram is correct? Let us look at this diagram. This is a wrong diagram. What is the mistake in this diagram? The mistake in this diagram is that we have not given the reading direction. And in this diagram, what is the mistake here? Given the reading direction here, but then the line association line is wrong, used a dotted line. What about this diagram? This is a wrong diagram. We have used a wrong arrow type. This is a correct diagram. This is a bidirectional arrow, which is also equal to which is just equivalent to a simple line. A simple line connecting two classes is same as they are being connected by a bidirectional arrow of this form. Now, there is another quiz here. Please read this diagram. Two classes, teacher and course, and we have the multiplicity that are written here and the association relationship and reading direction. How do we read this diagram? We can read as a teacher teaches up to 3 courses. A course is taken by either 1 or 2 teachers. A teacher teaches up to 3 courses. A course is taught by either 1 or 2 teachers. Now, let us try to read this diagram. A key opens up to 5 doors. A door is opened by many keys. Now, let us look at the concept of a link. We have so far seen that the association relationship exists between classes, and the objects of the 2 classes which are associated, a link exists between them, and therefore, we can say that a link is an instance of an association exists between 2 or more objects. The association relationship between classes is static in nature. We always represent the association, whereas the objects, as the system runs, the software executes, objects may get, the links between objects may get dynamically created or destroyed. For example, let us say we have an employee class and a company class. Let us say a person works for a company. A person works for a company, works for, and write the reading direction, and a company has many employees, write the star here. But when we look at the object diagram, let us say an object, let us say Ramesh, and there are other objects, and there are many companies, let us say Infosys, TCS, etc., etc. Let us say the company, the person Ramesh works for Infosys, a link exists between these two objects. But as the system runs, let us say Ramesh leaves Infosys and joins TCS, then this link gets dissolved and at the moment they have no link, and let us say after few months he joins TCS. So, a link gets formed between Ramesh and TCS. So, the association relationship is static in nature between 2 classes, whereas the links are more dynamic in nature, and these exist between the corresponding associated classes, objects of the associated classes. But can association be unary? That is, we have a single class and the association relationship is defined on that same class, a single class, and the association relationship is defined on that same class. Is it possible? If yes, give an example. Okay, there are many examples possible. We can write the multiplicity and we can use the arrowhead to indicate the direction of the association. And one example here is a person is a friend of many persons, or a person has many persons as his friend. A person has many persons as his friend, or a person befriends many persons. This is an example of a unary association. There can be many examples. This is another example. A computer connects to many other computer, or a computer is connected by many other computer. But how will the object diagram of this look like? A computer connects to many other computers, or a computer is connected by many other computers. How will the object diagram, if we have many computers, these are the computers A, B, C, D, etc. How will the object diagram of this look like? So, this is an object diagram. We have the computer named node 1, node 2, node 3, node 4, 5, 6, 7, 8. So, node 1 is connected to node 4, node 5 is connected to node 4. So, the node 4 is connected by 3 computers, whereas node 4 4 computers, but node 6 is connected by 1 computer. Now, let us do one exercise. Let us develop the class diagram. A person works for a company. We draw the person class and the company class, and then draw the association relationship works for, and the role is employee here, the role of the company is the employer. These are the implicit attributes. As you will see that when there is a association relationship, we need to create some implicit attributes, which we will look at very soon, and this is the name of the association. Let us see the implementation of this, that if this is the class diagram, that a person and a company works for is the association relationship, we will see the implementation, that how we can write the code for such a diagram. Then it will become clear that the roles become the implicit attribute type of the company. So, this becomes a attribute type of company, and this become the attribute type of the person. But before that, there is another quiz here. Please read the following diagram. If this is the diagram given, how do we read it? Okay, we can read here, not drawn the reading direction here, missed it. Just draw the reading direction here. Okay. So, a CPU has up to 2 controllers. A controller is connected to one CPU. the controller can be a quasi controller if we had other inheritance relations here, could have other types of controllers, but a quasi controller is a special type of controller, and a controller controls up to 1 to 4 disk drives, or we can also read a disk drive is controlled by one quasi controller. A CPU has 0 to 2 controllers, 1 to 4 disk drives are controlled by one quasi controller. One quasi controller controls 1 to 4 disk drives. A quasi controller is a special type of controller. So far, we looked at the relations between classes, generalization, association, aggregation, composition and dependency are not looked at, and association can be binary association or n-ary association, and a special type of binary association is aggregation, and a special type of aggregation is composition. We are at the end of this lecture. In the next lecture, we will look at aggregation, composition and the dependency relations. We will stop here. Thank you.